Now we're going to see the multi-hole problem. Multi-hole problem. This problem consists on, we have three doors. I will put it as boxes. Well, there are three doors. In one of them there is a prize, and in the others there is something not a prize, something bad. The person would select one of them, for example this, and then the person that is running the problem would show one of the other doors that are left, but the one that does not have the prize. So if the person selects this, the other person, the one that is running this, would show this door. And now the player needs to decide if that person will stay with this option, in which case the person would show now this, and it would be obvious that the player loses. Or if the person, after being shown this, the person decides to change to this, then the person would show this, and it would be obvious that now the player wins. So there are two decisions that the player needs to do. First is one of these is going to pick, and after one of the doors is shown, if the person will stay in with that option or will change. So if you think you can do it, stop the video now and next continue to see we have the same result. So we're going to calculate the probabilities of winning and losing if we change the option or if we stay with the option. So let's suppose that, yes, here is the prize, and in these two are the other things. So let's say that the person will not change the option. So here is no change. So the first, if the person selects this box 1 or door 1, 2, and 3. So if select door 1, then the person running the problem will show this. Then the person needs to stay in this or change to this, because we are saying no change. The person will stay in this, and so the person loses the game. So here is lose. And then if the person selects box 2 or door 2, the player selects box 2, then the person running the play or the game will show either of this or this, whatever it be. Let's say this. So the person again will stay with this option, and so the person will show this, and it shows that the player wins. So here, winning. And then if the player selects box 3, it's the same as box 1. The player selects this, the person will show this, and the player will stay with this one, so the person will show this, and the player loses. So here, lose the game. So here, if the person stays with the option that select at the beginning, then the player has 1/3 probability of winning and 2/3 probability of lose. So the odds of win to lose are 1 to 2. Now let's see if the player does not change, if the player change the choice. So here, change. If the player selects box 1, then the person will show box 3, and then the person will change to box 2, and the person will show this box. So it is obvious that the player wins. So here, wins. If the player now selects box 2, the person will show, let's say, this one, and the player will change to this, and so the person will show this, and so it's obvious that the player loses. The same if the player selects this, then the person shows this, the player moves to here, and then the person shows this. so the same thing. So then if the person selects box 3, the person will show this, the player moves to here, and the player wins. So here again wins. So here the odds are 2 to 1 of winning. So the best option is that whatever the player selects at the beginning, after the person shows one of the door that doesn't have the prize, then the person needs to change the option, because there is a 2 to 1 odds of winning, compared to if the player does not change the option and stays with the first selected choice, the player has 1 to 2 odds of winning. So if the player selects this, it will be shown this, and then the player moves to here, wins. The same for this box, and if selects this, then one of these doors are shown and then moves to the other. Well, in that case loses, but there is a 2 to 1 odds of winning, compared to here, that if stay with this option, then this is shown and stay with this option, so loses. The same for this one, lose, and for this, in that case, we win. Stays all the time with this, we win, but here we have a 1 to 2 odds of losing. So in the Monty Hall problem, contrary to intuition, the best option is, it doesn't matter what door we select at the beginning, then the next thing that we need to do is to change the option or the door that we select. So actually these are the odds of winning and losing given that we select the first choice, but actually the probability of winning with this mechanism of playing, it would be the probability of selecting the wrong box at the beginning, that is 2/3, and like that, it's just 2/3, because then if we select the wrong box at the beginning, we will change, and when we change, we are changing to the correct box. In here, the probability of winning is that we select at the beginning the correct box. So here the probability of winning is 1/3. So it's 1/3 compared to 2/3.